Okay, so I want to go ahead and use some of the derivative rules that we've been talking about, such as the power or the product rule and the quotient rule, in order to apply those with tables and graphs. So I have a table here for you. I have a table of x values, g of x values, and g prime of x values. I also have a graph, and notice the graph is f of x. And in addition to that, I have several different functions. I have the h function, which is the f and g added. I have the j function, which is defined as g of x minus 3 times f of x. I have the p function, the q function, and the r function. And there is a difference between the q function and the r function. Notice in the q function it's read as g of x divided by f of x, and the r function is f of x divided by g of x. So let's just review the product rule. And so the product rule says this: if I have y is equal to f of x times g of x, okay, then the derivative of y is equal to the derivative of the first function times the second function plus the derivative of the second function times that first function. And again, the f and g is relative, right? It's all dependent upon what functions are given to you. F and g might not always be given to you. And in the product rule, it really doesn't matter which function comes first in terms of which one do I take the derivative of first times the second function, because multiplication and addition can happen in any order. However, the quotient rule is different. For the quotient rule, again, if I have y equals f of x divided by g of x, again, we do not want g of x to equal 0. It does matter which function is the top function and which function is the bottom function, because within that quotient rule we're subtracting, and order does matter with subtraction, and the denominator of the quotient rule is dependent upon the denominator of the given function. So y prime would then be equal to the derivative of whatever function's on top times the function on the bottom minus the derivative of the function on the bottom times the function on the top, all divided by the function on the bottom squared. And now we're going to take these and apply them. Okay, so I'm going to do problem 1 and 2 and 3 with you, and then in class we'll take care of the backside. Okay, so h prime of negative 1. The first thing that I want to do is I want to write out what h is. I just want to remind myself h of x. And I'm getting h of x by looking up at this list of defined functions, okay? H of x is defined as f of x plus g of x, okay? So I'm just reminding myself this is f of x plus g of x. And one of the rules we had is that when I go to take the derivative of a sum of terms, I can simply find the derivative of each individual term. So I don't need the product rule or the quotient rule because I'm not multiplying or dividing anything. All right, and then specifically I'm being asked to evaluate h prime of negative 1. Okay, and so that means that every place there is an x, I'm going to write negative 1. And now the question is, where am I getting the outputs for f prime of negative 1 and g prime of negative 1? Well, remember, these represent the slope of a line. All right, so the f function is this graphed function here. This is the graph of f of x. And specifically, I'm looking when my x value is negative 1. And if I'm looking for f prime of negative 1, I'm looking for the slope at negative 1. And the segment I have at negative 1 is a horizontal segment, and that slope is 0. So f prime of negative 1 ends up being 0 plus, okay, g prime of negative 1. Well, I have this g function. This g function is in this table here, right? Here are the x values, here's g prime. And I'm specifically looking when g has an x value of -1, okay? And so g prime of that also ends up being 0. Who makes these problems? Hassler. And 0 plus 0 equals 0. Okay. All right, so let's do the same thing with 2. With 2, again, I'm just going to remind myself what this j function is. And j of x is defined up above. J of x is g of x minus 3 times f of x. Okay, so g of x, g of x minus, I was hoping it wouldn't hop on me again, 3 times f of x. Okay, and again, I'm adding and subtracting these terms, okay? So when I go to take this derivative of j, so j prime of x, when I'm adding and subtracting terms, I can just take the derivative of each individual term. The other piece is that I have this coefficient, and one of the properties was that when you have a coefficient with your function, then you keep that coefficient with your derivative. So I'm just going to drop that coefficient and multiply that by the derivative of f. So this is, I do not need a product rule here. Anytime I have a constant coefficient, I just keep that constant coefficient with my derivative. And then again, the whole idea is that I am going to replace all my x values with 5 because my goal is to find j prime of 5. So I need to figure out what g prime of 5 is minus 3 times f prime of 5. And again, for the g values, I'm going up to my table. G prime of 5 is 2 minus 3 times, okay, remember, f prime is the slope at 5. So here's my 5, and I want to know what the slope of this line is. So I could just pick 2 points on the line and count the slope till I get there. Looks like -2/3. Which is super nice because if I'm going to multiply -3 times -2/3, I'm going to get +2, and 2 plus 2 is 4. So j prime of 5 is 4. Okay. And the last one that I'm going to do with you here is p prime of -3. And so again, I'm just going to look up at the top to see what the p function is defined as. Here's my p function. Oh, look at that. My p function is a product. Okay, so p of x is f of x times g of x. I'm just writing this down to remind myself, so I don't have to keep scrolling. Okay, so this is a product. I don't have a constant coefficient. I actually have 2 individual functions. And so since those are being multiplied, I have to go ahead and use my product rule. And the product rule says derivative of the first function times the second function. Trying to get used to a new board, right? With switching rooms with Mr. Thompson. So please bear with me. I apologize. Okay. Times g of x plus the derivative of the second function, g prime of x, times f of x. Okay, and now I want to evaluate this at -3. So p prime of -3 equals f prime of -3 times g of -3 plus g prime of -3 times f of -3. Okay. And again, I'm going to go up and I'm going to look at the slope. So for f prime of -3, I need the slope of the line at -3. So here's -3. I need the slope of this line. Looks like the slope's going to be -2. So the slope of the line for my f function at -3 is going to be -2. Okay, notice it's g of negative 3. So when I look at my negative 3 for my x values, I'm looking specifically at just what g of negative 3 is, not prime. So you got to be careful. G of negative 3 we had was negative 1. Plus, okay, now I want g prime of negative 3. And g prime of negative 3 was 4. I know, lots of scrolling, sorry. And then f of negative 3 means that I actually want the output when x is negative 3. I want the y value, and that y value is 0. Ah, I had a feeling that that was going to happen. All right, 0. And if I multiply these through and add these together, I get 2 plus 0, which equals 2. So p prime of negative 3 equals 2. And so now you have a sense of how we use these tables and graphs and these defined functions to evaluate this. So we will go ahead and work together in class on the back side of this because there are some more things that I want to note, but I just wanted to get you guys a head start. All right, see you later.